And so then once we multiply by the LCD, we're going to have some kind of expression. It could be linear or quadratic, and then we know how to solve that expression. But one little thing that we have to be careful of is when we clear the denominator, we have to go back and look, because sometimes we get answers that make the denominator 0. And can the denominator be 0? So I'm going to put a little star here. We need to make sure we check afterwards for extraneous. Have you heard of that word before? Extraneous solutions. They don't work in the original. Okay, that is not banned anymore, huh? So here we go. Let's start with something, and you guys got to remember I can't do every single type of problem, but you got to remember the least common denominator sometimes is just the only denominator, and so that's what the first one looks like. So if I said solve this, x plus 3 over x equals 4. So the least common denominator is the only denominator. What's the only denominator we see here? X. So here's what we do. If I want to clear the fraction, I have to multiply both sides by that least common denominator, and it's going to get rid of the fraction, and it might change the other expression. I'm going to multiply this side by x. Why did I choose x? Because it's the denominator here. And I'm going to multiply this side by x. Make sure you do this side. Alright, when I do that, we need to distribute this. What's x times x? X squared. When I do x times 3 over x, that was the one why I did this. Doesn't that, the x's on top and bottom cancel? So I'm left with plus, not 3x because it's on top and bottom, just 3. And then on this side it's 4x. Okay, this is quadratic, so to solve a quadratic we have to get a 0 over here. I'm going to subtract the 4x off. So we have x squared minus 4x plus 3 equals 0. Alrighty. Can we factor? If we can't factor, what can we use? Quadratic formula. But I think we can factor this, can't we? X minus 1, x minus 3? So now we set these each equal to 0. What are my two solutions? Yep. Now, if you go back, we have to check and make sure, do either of these make the denominator 0? No. So these both should work, and you could even in your head put them in. If you did 1 plus 3 over 1, don't you get 4? And if you do 3 plus 3 over 3, you also get 4. So they do work. Okay, let's do one that has two different denominators. Okay, so we're going to solve 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. Okay. So now, I would not do this if they were totally two different linears and two different quadratics. What happens when you factor the denominator over here? You get these two things. Actually, those are the same two factors we did before. It's not the same problem, though. All right, so I'm going to rewrite this as 2x over x minus 1, so I'm not changing anything, plus 1 over x minus 3 equals, I'm going to just write this in factored form.
Can you move it up, please?
I sure can. So the least common denominator is the smallest denominator that clears all of them, okay? Because if I said, well, what's the smallest denominator? Well, it would be x minus 3. But the one that would clear all of the fractions would be this one when they were multiplied together, the x minus 1 and the x minus 3. So I'm going to choose to multiply both sides by x minus 1 times x minus 3. That would be its least common denominator. So let's do that. So on this side, I'm going to multiply by x minus 1 times x minus 3. And then also on this side. Okay, so when I do this, well, let's start with the easy side. On the right side, what happens? The x minus 1 on top and bottom cancels, and the x minus 3 on top and bottom cancels. I'm going to be left with just a 2. And then on the left side, when I do the first term, so let's say we're doing both of them. By this first term, do you see that they have an x minus 1 and an x minus 1 on top and bottom? So I'm just going to cover those up. Those are going to cancel then. But what am I going to have left? X minus 3 times 2x, right? Okay, so let's write that down. Okay, so when I multiply those two expressions, the x minus 1's cancel. I'm left with x minus 3 times 2x. Now when I go to the next one, what happens? This time the x minus 3's cancel, and I'm left with plus x minus 1 times 1, which is just x minus 1. Alrighty, let's do some work then. So I'm going to distribute. What do I get here? 2x squared minus 6x plus x minus 1. Right at this time, I'm going to subtract the 2 from both sides because I see it's quadratic. So now I have 2x squared minus, what is this, 5x minus 3 equals 0. Okay. Has anybody tried to factor it yet? No? Once again, I know you guys know how to do quadratic formula. We've just been working on it, right? So if you want to plug it through quadratic formula, that's fine. I'm going to try to factor it and see if I can. Remembering this equals 0. See. So this has to be a negative 1 and 3. If I would put a negative 3 here, get negative 6x. Plus 1x, which gives me negative 5x. if 2x plus 1 equals 0, what would we do? Subtract 1, divide by 2. X equals negative 1/2. I'm just going to look up here and check a minute. Would that have made either of the denominators 0? Nope. So it's okay. And then the other one is x minus 3 equals 0, so x equals 3. I go up and check. Does that make any of the denominators 0? It does. So I'm going to put it here, and then I'm going to just lightly do this. This is called extraneous. It happened when we cleared the fraction out, because when we cleared the fraction out, we were multiplying by another expression, but it does not work in the original. It would not be an actual solution to that problem. How we doing? So there's an example of something that is extraneous.